So this is the paper that was on the ground that I put on the board here. This X was the spot that marked where the washer or where the weight hung down from the table. And so I put an X there, and see how I've turned the paper now so that that X marked the origin, and the X-axis here I've drawn in, and the Y-axis was the straight line. And this was the line, and that was the mark that was made when we had the ball with no collision. So just the ball with no collision is the Y-axis, and the two other dots were when the balls collided and where they landed. And so what I've done is I've drawn a straight line from the X to those 3 points that I marked after the collision. And now what I did is then I measured these distances and recorded them there on the paper. Now what we need to figure out is the time that it took the ball to land on the floor. And for that, we'll use one of the equations that we've learned, which is D equals VIT plus 1/2 AT squared. This is what we'll use to figure out the time that it took the ball to land. The initial velocity, like we do with anything in free fall, we say that it's 0. The distance, I've already calculated the distance or the height of the table, and I calculated it to be 0.74 meters or 74 centimeters. So we'll write 0.74 as the distance equals, this term goes to 0 since the initial velocity we take to be 0. So that will equal 1/2 times the acceleration due to gravity, which is 9.81, and then times t squared. So solving for t, we get, solving for t in this equation, we get t equals 0.3884 seconds. And I'm not going to round these numbers too much because we don't want to have the rounding contribute to our error in this experiment. So here we have the time that it took the ball to land on the floor, and that's the same time that we'll use for all 3 of these. What we want to do now is we want to figure out the velocity of each ball. So the first thing we're going to do is figure out the velocity of the ball that did not hit any, and so that was the momentum without the collision. So we have a distance of 38.3 centimeters and a time of 0.3884 seconds. Therefore, our speed, or our v in that direction, will be our distance divided by our time, and we'll have to convert that distance into meters. So we'll have 0.383 meters divided by our time of 0.3884 seconds. And when we do that, we get a speed of 1.13 meters per second. Doing the same thing for this ball and this ball will give us those velocities. So the velocity here, or the speed, will be the distance. We'll have to change it to meters, so 0.34 meters divided by our time of 0.3884 seconds gives us a speed of 0.8754 meters per second. And then we'll do the same thing over here. Once again, our speed will be our distance over our time, so 0.248 meters divided by our time of 0.3884 gives us a speed of 0.6385 meters per second for that ball. From here, we need to figure out what the 2 components are for each vector. We'll treat these as vectors now. Well, this one along the y-axis has only one component, and that's 1.13 for its speed, and it's all in the y direction. Therefore, it will have a horizontal component of 0 for its velocity. we'll figure out the components of this vector by drawing a straight line down, and then we'll have this line going over. And then when we do that, a straight line down. Now we can treat this as a right angle. So that will be our right angle. In order to do trig here, we need to figure out what that angle is. So we'll use a protractor, set it up here, and you can read your angle here of, we have 80, looks like about 86 degrees. So we'll use that. So our hypotenuse in this case is that velocity, and to figure out both your y and your x component, you'll be using trig. So for our y component, we'll have velocity in the y direction equals our hypotenuse times, when we find the opposite component, we're always using sine. So we'll have sine of 86 degrees. This will give us a velocity in the y direction of 0.8733 meters per second. You'll do the same thing to find the x component. That will be 0.8754 times the cosine of 86 degrees, which gives you 0.0611 meters per second. Now I've done the same thing over here for the other vector as I did for the vector that I had on the right. So I found the vertical component, or the y component, by taking the speed times sine of 52 degrees, and I determined that using the protractor. And then I found the velocity in the x direction by taking the speed of this vector, or the hypotenuse, 0.6385, and multiplying that by cosine of 52 degrees.